So, good morning. Welcome back to my channel, JBTeguihanon Engineering and Chemistry Tutorial. So, let's review and have a sample problem here for the review of the following items. So, the frictionless piston shown in figure. So, we have a figure here at the right side of the presentation. Has a mass of 16 kilogram or kg. Heat is added until the temperature reaches 400 degree Celsius. If the initial quantity is 20%, so it has a given quantity 20%, find A, the initial pressure, B, the mass of water, C, the quality when a piston hits and stops, and D, the final pressure, and E, the heat or the work done on the system. So work done in the system. So let's solve this one. So a force, for A force balance on the piston allows us to calculate the initial pressure. Okay, so we need to have a force balance. Okay, so what we have is actually the weight of the piston. We have the weight here going down, right? Okay, call it weight. Of the piston, and of course we have the pressure or the force going like this, F, right? So because that the F is acted upon by the pressure of the water when you heated it, so there is a pressure. Okay, and if we and then we include, of course, the atmospheric pressure. Atmospheric pressure is acting actually on this here, right? The atmospheric pressure, or on the surface of the piston, because this is open, right? This is open to atmosphere, so this is open to atmosphere. Therefore you have to account the um, atmospheric pressure. So what we have is the pressure, the F. Okay, and F can be expressed in terms of pressure times the area of the piston, that is actually equal to W, right? This weight here plus D. Since you have atmospheric pressure on top of this, right? PATM, you have a PATM acting on this, ATM, atmospheric pressure, so that is P ATM, right, times the area of the piston, right? The area of the piston. Okay, so what we have is of course is the pressure, this pressure, I call it pressure 1. Okay, you have here a pressure actually. That is where your PE or P1 is, right? Because the water pushes back the water vapor pushes this pressure P1 push the piston up, and your W, this guy here, is making your piston down, okay, along with the PETM, but of course it resisted by the pressure of water vapor. That's why we equate it. So if we put in or plug in this value here, okay, if we consider that, then it would be P1. So your area here is the area of your cylinder. The area of your cylinder is like this. It's round. Sorry, and that also comprises your piston, right? Okay, with this diameter. Okay. If you look at it from top view or bottom view, you can see it's round. Right? Okay. So what we have here is pi 0.1, okay, square over 4. That's the area of our circle. That is equal to 16. That's the kilogram or the mass of your piston. And then you have the pull of G, gravitational acceleration, right, plus the atmospheric pressure. We use 100,000 Pascal, okay, times the area, pi 0.1 square over 4. Okay, and then we plug into the formula and perform numerical calculation. We are going to have P1 is equal to 120 Pascal, or we have 120 kilo Pascal. Okay, this is what we got for A. He is asking for the initial pressure. So the key is understanding of the forces that are acting on the system, on the boundary of the system, and inside the system. Okay, and then we go to the next slide so that we have space to use, right? So the next question is what? The next question is find the mass okay, finding the mass. So B is finding the mass. So to find the mass, we need the specific volume, right? Specific volume. Specific uh, volume. Okay, but in this problem we use table, of course, right? So to find the specific volume, we need a table or stem table. Okay, and plug into the formula of V1, your pressure at initial condition is equal actually to specific volume of the fluid plus X, okay, times quantity specific volume of gas or vapor minus specific volume of your liquid. Remember, you in our P diagram, no? P specific volume diagram. Oh, this is your pressure. It's gonna be like this, right? Okay, and in this area here, if you have a process of constant volume pressure processor, you're gonna have a guy here. This guy, you have this is your VG minus VF. Okay, and you have to multiply it with the value X, and that is actually the quality of your the quality of your the quality of the substance. Okay, so this is just a review, and then because this is saturated vapor line, this is saturated liquid line, so in between, so you will have this expression. Okay, and then of course this is a liquid area or region, this is vapor region here. So of course I will not show the table. Okay, we can have the value V sorry, this is specific volume 1. Okay, this is specific volume 1, not yet, not volume, but specific volume 1 is expressed by this guy here, specific volume at this point, at specific volume at this point. This is VG, and this is VF plus the percent quality of your substance. So in this case, of course, water. So we plug in this guy here. Suppose I have the value, which is point, and we have the value 0.001 plus 0.2 and quantity 1.2 I look at it from the table. Okay, and then this is the value 1.42628, sorry, point minus 0.001. So what you got is 0.286, and the unit is cubic meter, of course, specific volume per kilogram. This is actually the uh, V1. So therefore your mass is equal to V1, now that's the volume, over specific volume 1. That is actually equal to 0.05, right, over 0.286. Okay, perform numerical calculations. Your mass is equal to 0.01373 kilogram. Okay, this guy here. Right? Okay, that's all for now. I will continue uh, the calculation for C, D, and E in the next video. Thanks for watching. Please subscribe to my channel, JBTeguihanon Engineering and Chemistry Tutorial. Bye for now. God bless.